hello to you wherever you are. I really wish I could be in Raleigh live with y'all this morning, but you know, it's the year of 2020 that just keeps rolling into 2021. So instead, I am coming to you live from one of the Google offices in Seattle, Washington. And I really, really do mean live. It is, just after 8 here, the sun has just come up. We got a gorgeous day here in Seattle, but that's pretty unusual this time of year. It is normally really dark and gloomy, and I feel like dark and gloomy might be how some of you will be feeling about the security of your open source projects. I know that open source security has kind of been, it's the trending topic. It's the thing everybody's been talking about for the last 2 years. And the last 12 months in particular, it's been supply chain, supply chain, supply chain. The other day, I ran a Twitter poll, very scientific, just to see how are people feeling about this? And it was sort of split down the middle of respondents. Folks feeling like this is just a bunch of hot air, this is the trendy thing, there's nothing actually here. And others feeling like I'm terribly overwhelmed. I understand what the problems are, I know this is a huge issue, but I don't know what I'm actually supposed to do. I'm actually really excited that we're all suddenly focused on open source security. I think there's a lot of work here, and a lot of these problems aren't terribly new. The good news is that because they're not terribly new, we actually have some solutions for them. With initiatives like the Open Source Security Foundation, we're going to see those solutions evolving and improving, but that still means that there's things that you can do today. And that's the part I want to talk about. I think sometimes we end up feeling, either like this is just a trendy thing and I don't need to pay attention to it, or I'm really overwhelmed when we forget to remind people what they can do to address the problem right now. So that's what I want to focus on. Let's take a quick look at this diagram that you're probably becoming pretty familiar with, which is the development to deploy lifecycle. And you're seeing across here some threat vectors. Threat vectors are the pathways an attacker can take to compromise a system. Now, we kept it simple this morning, so there's only about 8. There could be plenty more. But from a mitigation perspective, if there's 8 threat vectors and they all exploit the system a different way, that means there's 8 different things you have to do to secure your project. Now, I could read these off a list, but I know we're, the last keynote on the second day, so I figured let's get some energy going. Instead of reading off a list, let's play a game. So whether you're at home or you're live in Raleigh, I want you to join us on slido.com/, the game code is ATO. You can do that on mobile or on desktop. And why don't you go ahead and take a minute, pop on, and I'll tell you how this is going to work. There will be 8 multiple choice questions. You'll have about 30 seconds to answer each, which I know isn't very much, but attackers move pretty quick. Let's see if we get some folks coming on. Oh, good. I can see people rolling in. Excellent. Oh, you're excited to play. These are some creative names. I love it. Oh, good, good. Oh, this is amazing. There's so many of you joining us this morning. This is really awesome. I'm going to go just a few seconds more. Let people log on. We got to traverse the world with all our connections. Oh, this is fantastic. We have such a good group. Thank you so much for playing with us. It's going to be fun. That counter just keeps going. Okay, let's go ahead and move to a practice question while people join. So this one's a little bit of a gimme, but you've got to get used to the system. So the all things open crew are fantastic, super fantastic, or superhuman fantastic rock stars. You have about 15 seconds to answer. Five seconds remaining, and hopefully this is pretty easy. I saw everybody having a good time on day 1 yesterday. Let's see what the audience says. Superhuman fantastic rock stars, that is also the correct answer. Thank you so much to the ATO crew for, hybrid is a whole challenge, so I'm really glad y'all pulled it off this year. Okay, now let's jump into the supply chain bit. So, question number 1. What should you do to protect your developer accounts from takeover? Use a shared account for core maintainers. Make sure to write all your passwords in ROT13. Use multi-factor authentication, or use an IP allow list. About 10 seconds remaining. And if you haven't played with ROT13 before, it's a really fun ciphertext, something to do for a weekend project. Okay, Let's see what the audience says. Oh, 90% for using multi-factor authentication, and that is the correct answer. Great job. So you want to make sure you're using multi-factor auth, and if you can get a security key, that's even better. It's hardened against things like phishing, whereas an SMS is your second factor isn't. And you're going to want to apply that not only on your developer accounts, something like GitHub, but also on accounts associated with that, so like your email as well. So let's go ahead and jump to question number 2. And if you haven't joined us yet, you can join this quiz at any time with that game code ATO. What should you do to avoid merging malicious commits? Only accept commits from contributors who have accounts older than 1 year, require all commits to be reviewed by someone who is not the commit author, auto-run tests on all commits, or scan for the word Bitcoin in all commits. About 5 seconds remaining. Okay, let's see what the audience says. Ooh, a good chunk said auto-run tests on all commits, but the correct answer is the majority of you, which is require all commits to be reviewed by someone who is not the commit author. So self-merging, also known as a unilateral change, that's when we would let someone, merge in their own commit. And that could also let a malicious actor do the same thing. I know for some projects, it's really hard to have that second person review. So, maybe put it on your project growth timeline of a place to try and get to. But that second person review also, if someone well-intentioned sends something in, accidentally introduces a security risk, gives someone else a chance to catch that second pair of eyes. Let's jump to question number 3. How can you protect secrets used by your CI/CD pipeline? Store secrets in a separate repo, store secrets as environment variables, appoint a maintainer to control secrets access, or use a secret manager tool. About 10 seconds remaining. And remember, these are secrets like, for example, a Maven token or something, not a password for an account. Let's see what the audience says. Ooh, 3 for 3, well done. Majority said use a secret manager tool, and that is correct. So we want to use the security principle of defense in depth, meaning we're going to try and have multiple layers that have multiple different mechanisms in front of our system. And with the secret manager tool, we're abstracting that way out of our source code, so you're not hard coding secrets in, and we're also adding a layer of authentication. So a couple different things going on there to protect your secrets in your CI/CD pipeline. Let's go to question number 4. Y'all are doing so good, 3 for 3. What should you do to protect your CI/CD system from abuse? Run CI/CD systems locally, use access controls following the principle of least privilege, run integration tests on all pull requests and commits, mark all contributors as collaborators through GitHub roles. You have 10 seconds remaining. Okay, let's see what the audience says. Excellent. Oh my gosh, y'all are so good. Use access controls following the principle of least privilege. That is correct. So the principle of least privilege, it's the idea that we only want to give folks the least amount of access they need to get whatever they need to get done. And by doing that, we're also protecting our CI system, those compute resources under it, from abuse. So things like, crypto mining, crypto jacking, giving a little extra layer by not being overly permissive. Okay, let's jump to question number 5. What should you do to avoid compromise during build time? Define build definitions and configurations as code. Make your builds run as quickly as possible so attackers have no time to compromise your code. Delete build logs to avoid leaving clues for attackers. Use only Lego brand components in your build system and do not accept any substitutes. About 3 seconds remain. Let's see if the Lego lovers can pull it off. Oh, excellent. With 82%, that is the correct answer. Define build definitions and configurations as code. So by having that build definition in its own file gives us kind of hardening for malicious actors tampering with that, and also prevents you from having to do your builds manually, which could introduce an accidental misconfiguration. You all are doing just incredible. Let's jump to question number 6. We got 3 left. We're going to talk about dependencies, everybody's favorite. What should you do to evaluate dependencies before use? Check for a little lock icon next to the package URL. Use only dependencies that have a minimum of 1,000 GitHub stars. Use only dependencies that have never changed maintainers. Assess risk and transitive changes with tools like scorecards and deps.dev. Have 5 seconds remaining. All right, let's see. Oh my goodness, this is 95%. Excellent. Assess risk and transitive changes with tools like scorecards and deps.dev. That is correct. So if you're not familiar with either of these tools, scorecards is a security health metrics assessment. It can look for things like, does this project use multi-factor auth for its committers? Does this project use GitHub's branch protection, avoiding that unilateral change that we were talking about earlier? And deps.dev is a visualization of both a package's first line and transitive dependencies, and it'll pull those based on, do a diff on versions. So you can see if I bump this version, do I accidentally introduce something that's going to be an issue for me? And there's really no way, to definitively say this is a good package, this is a bad package. It's all about what your security posture is, what your risk tolerance is, and the more information you have from tools like scorecards and deps.dev, the better decision you can make for yourself. So you all are doing just fantastic. We've got 2 more questions. Staying in the build system, what should you do to ensure your build is the build you think it is? Check the last commit to be sure it's from a trusted committer. Use a build service that can generate authenticated provenance. Run conformance tests for each release, or use steganography to embed your project logo in the build. Have 5 seconds remaining. Let's see what the audience says. Oh, excellent, with 81%, the correct answer, using a build service that can generate authenticated provenance. So that provenance is going to tell us the origin of the build as well as the artifacts used. And if it's signed, we can compare that to the hash of the signature and make sure that this build is the build we think it is. You all are doing amazing. 7 out of 7 so far. Let's see if we can make it 8 out of 8. Last question. What should you look for when selecting artifacts from a registry? That artifacts are not cursed. Look for timestamps and use only the most recent artifact created. Look for an official endorsement, like the logo of a trusted brand or standards body. Or look for artifacts that have been cryptographically and verifiably signed. 5 seconds remain. See if we can make it 8 out of 8. Can the audience do it? Oh, yes, they can, 91%. Excellent. That is the correct answer, that artifacts have been cryptographically and verifiably signed. So the same way that we are going to want to sign our own builds, we're going to want to look at that when we're using artifacts from others. Now, I know we went through these questions really fast. 30 seconds for each one is not a lot. And we didn't have much time to talk about why each answer was the correct answer and the tools that you can use to implement it in your own project. So if you go to goo.gle/OSS-supply chain, the link at the bottom here, you can pull that up and it'll be a blog that's got those questions, got the correct answers, and a little bit longer of an explanation of why that answer is the right one and tools you can use to implement that in your own project. I want to thank the All Things Open crew so much for having us. I want to thank you all for being passionate about open source, for contributing to open source, and I wish you the best of luck on your security journey. Thanks so much.